I'm James Johnson, and you're watching Niagara Pro Tips. Hello, and welcome back to the Niagara Pro Tips. This is the part 2 in the schedule relations series, and if you haven't watched part 1, I'd suggest maybe you go back and watch that first. In the part 1 video, I cover setting up tag rules and to apply smart relations and tags to some schedules and points in the stations, and then demonstrated how to visualize some of that with PX. In this video, I'm going to focus on using those same relations and tags to build hierarchies. And just a little quick review of the situation and how things are set up. This is my J station here with Greenbrier, and under that there's a LAN network with device folders and devices, and we can see that in the nav tree here as well, under drivers, LAN network, and the different floors and those devices. Each of those devices have control points set up underneath them, and those control points all have a inbound parent device relation from the point to the device. There's obviously also an outbound child point relation, but the main one that I'm interested in here is probably going to be the parent device relation. The reason for that is the occupancy point also has an inbound schedule ref relation, schedule ref, coming from the applicable schedule, which is controlling that occupancy point. So with hierarchies and equal queries, we can traverse relations in the same direction, but we can't use opposite directions in the same equal predicate. So I'll probably be utilizing that parent device relation since the schedule ref relation is inbound as well. All right, so taking a look at the hierarchy service in the J station. So this is under your services in the hierarchy service here. I can drag in a new hierarchy here and maybe call this my schedule hierarchy. I'll expand the schedule hierarchy here, and then we can drag in a query level def component. And this will look for the schedules in the station. Now, just a reminder, these schedule objects have an schedule tag on them, but I did create a tag rule to assign a weekly schedule marker tag to them. And the reason for that is just that the schedule tag applies to any schedule in the station, like trigger schedules, weekly schedules, day schedules, and so forth. So I wanted to narrow this down more easily in my hierarchy using the weekly schedule tag. So in this case, it would just be a simple equal predicate here saying weekly schedule. Now, this is going to find any of those schedule components, which are in this case under my home folder, under my schedules folder, and there's a number of schedule components here that have that weekly schedule tag assigned to them. At some point in time, I'm going to want to show specific equipment that is controlled by that schedule. So I probably need to put something into the query context here to help me identify that. And looking at the tags on any of these schedules, I can see that there's a name tag, display name tag, and so forth, and then the HSID tag. In this case, I think I'm going to leverage the HSID tag, which is from the Haystack Tag Dictionary, because it's possible that I could have more than one schedule named first floor weekly in the same station, right? They would have a different slot path, but it's possible that they could have the same name, whereas the HSID uses the handle ord, which should be unique in the station. So my plan then is under the query context here, I'll add a new key here to the query context, and I'll just call it sched ID. So SCHED and then a capital I lowercase d. And the value of that is going to be the HS:ID tag. So what we're going to do, what this does is it will read the HSID tag value, store it in the query context using a variable named sched ID here. So that way we can access that later in the hierarchy elements. If I refresh my hierarchy here and look at it, I'll have the schedule hierarchy, and when I expand that schedule hierarchy, that should find all of those schedules, which are the weekly schedules that have that weekly schedule marker tag on them. Now, once I've found the schedule in that group, we're going to look for things underneath the station that are controlled by that schedule. And ideally, I probably want to look for the devices, because the devices are what have the PX views assigned to them. Probably don't want to just look for the occupancy points. It'd be more useful to show the equipment with the graphic link. So in this case, we could look for things maybe that have the HS equip marker tag on them, and also which have a parent device relation, which comes from some control point, which also has a schedule ref relation, right? Which relates to this component, which has an HSID tag on it that matches the value that's stored in the query context. So going back over to the hierarchy service here, I can add another query level def to my schedule hierarchy here, and I'll call it maybe equipment. And then for the query, I'll start off and say I'm looking for anything with the HS equip marker tag that also has an n: parent device relation that's inbound, and whatever that component is that is related, the control point also has a b: schedule ref relation that's inbound. And when it gets to that endpoint, which will be one of those schedules, I can check the HSID tag value equals, and then this is where the magic is using the curly brace. So I'm going to put an opening curly brace and then the name of the variable that I've stored in the query context, and then a closing curly brace. So it might be hard to see on the video, but it's not a parentheses, it's the open and close curly brace on either side of the variable name that's stored in the query context. So if I refresh my hierarchy nodes here, I only have to do this because I'm modifying the hierarchies and I had already looked at them. So when I expand the schedule hierarchy now, and then I select a specific schedule and expand it, this should now list the equipment, which has an occupancy point, which is linked in some way or form or fashion to the schedule, for say first floor weekly or second floor weekly. And you can see the applicable equipment is there shown under the hierarchy. Right. Now, this is working in the local J station, and the J station is mapped into the supervisor station through the Niagara network. Obviously, here's my Greenbrier station. And if I want to build a hierarchy at the enterprise level, then I most likely need to use system database so that I can get all the tags and relations indexed from the JACEs into the supervisor station. So it's really beyond the scope of the video to really get into all the details about the system DB service, but I do have the system database service set up in my station, and it is enabled. And typically under the system index service, you have your Niagara network indexer and the global indexer here. And what I would need to do is make sure that I've gone through and invoked the action, or let it invoke on the schedule, but that will cause the system database to go index the things in the remote station, which will include the schedules, the control points, the devices, the networks, and so forth. So I have already gone through and indexed the remote stations, so I don't have to repeat that process right at the moment, but just showing you how that's done or where it would be done from. And what I'm going to do is copy my schedule hierarchy from my JACE, and I'll go to the hierarchy service in my supervisor. So this is the hierarchy service in my supervisor, and this is the tab that I'm looking at here, and I will paste that hierarchy into the supervisor. Now, I probably want to have a little bit of organization here, because it's possible that there's the same schedule names in multiple stations and things like that, and I probably want to at least maybe organize things under the hierarchy based on the name of the station where the schedules are located. So in this case, I might use a group level def component and drop that onto my hierarchy here, and I'll just call this stations. And I can reorder the components here and put the stations component at the top here. And what I would do is need to use some value tag here to identify the stations, and each component that comes from a station has an n:"station" tag on it, which has the station name as the value. So just by using the n:"station" tag, that will give me groupings under the hierarchy with each of the station names. Now, because I copied this hierarchy from the J station where I used this hierarchy component, the scope of the hierarchy is set to the station space, actually, to the config. And I could have drug out a systemdb hierarchy here, which I'll show you a little bit later in the video, and it is already configured for system database as the scope. So what I'm going to do here is change my scope from station : to sys : which is going to tell the station that for this hierarchy, search the system database for anything that has the station tag on it, and it'll populate the folders with that information. So if I take a look at my hierarchies, you'll see the schedule hierarchy, and when I expand it, I will see folders for each of the stations, or for any of the n:"station" tags with unique values that are in the system database. So I've indexed the supervisor itself as well as some remote stations here, and so those are the 3 folders that I see. Now, underneath the stations folder here with the group level def, we're still going to have the query level def that looks for anything with the b:"weekly schedule tag, and it will organize those underneath the applicable stations that those schedules have an n:"station tag that matches the name of the folder that it's under. And as I mentioned, you may see the same schedule name in multiple stations here, but that's why I wanted to kind of organize things by folders. And there's other schedules maybe that, like Global Boolean Weekly, exists in Greenbrier but doesn't exist down in the Vicom Pro J station. Okay. Again, we're using the same query here, looking for things that have the equip marker tag on them that are in the system database, that have the parent device relation, that also has a schedule ref relation, where the HSID tag matches the schedule ID tag. So in that case, everything should hopefully still work for me here, just like it did in the JACE. The only difference was I changed my scope to the system database, added a station group level def using that station tag, which is giving me the organization of the station names. But other than that, the same hierarchy is working in the supervisor that was working in the JACE station. All right. Now, as common as it might be to have the schedules in the remote station in the JACE, it's probably equally as common to have global schedules maybe in the supervisor. So maybe I have a global weekly schedule in the supervisor, and in the JACE station under the Niagara network connection. So let me kind of collapse some things here to make it a little bit easier to find. Under the Niagara network in the supervisor connection, there's a schedule device extension. So in this case, in the JACE station, I'm importing that global weekly schedule along with some other schedules here as well, but I'm importing this schedule from the supervisor station. And we can see that it's looking at the slot path of the schedule in that supervisor station, which is under this global schedules folder, that global weekly schedule. That's what's being imported into the JACE station. When we look at the supervisor station under its Niagara network, there's a Greenbrier station connection here, and that Greenbrier has a schedules extension as well, right? And when we look at that, we'll see that there's actually under the schedule export manager, there is a schedule export at that end, which is telling it which schedule it should be exporting. All right, so unfortunately, relations don't span stations, so we won't be able to create a relation from the supervisor station to the JACE station to help us understand which schedules are imported into the JACE station. And this is a case where we're probably going to need to use a smart tag, which would simplify the process. You could use a static tag, just a string tag or something else, but it would require more manual configuration. And we could do this using a tag rule in the JACE station and the supervisor station. And so in order to do this, I want to add a tag to the schedule in the supervisor station to help identify the slot path. And I want to add a tag to the schedule import in the J station so that it knows which schedule from the supervisor it was imported from. And to do this, we'll add a couple tag definitions, again, because we want people to know about these tags and know that they might utilize them. So I'll just drag a string marker tag to my tag definitions here in my building dictionary, and I'll call this sched import. And then I'll drag another string tag just as a definition, and I'll call this sched export. Just to make people aware that the tag might exist somewhere in the application. In the JStation then, utilizing my tag rules, I have already my weekly schedule tag rule, which is looking for these schedules under my home and schedules folder that have a name ending in weekly, and it's adding that weekly schedule marker tag and that schedule ref weekly schedule relation already. What I'm going to utilize here is from the Vicom Pro module. We have a smart tag here called a format tag, and this uses a B format to resolve against the component, and it returns a string. So I'm going to add this B format tag, and I'm going to give it a tag ID of sched import, which is what I just defined under the tag definitions. Now, I need to identify the station that this is coming from, and I also need to identify the slot path in that remote station. In order to do that, there's a couple of bits of information that we can utilize here. Looking under the supervisor connection under the Niagara network, the schedule import or schedule device extension is here, and then we have the schedule import extension that's underneath the schedule that's being imported here. So starting at this point here, this is the schedule that we're finding with the tag rule. I can go up one level as a parent, which is the schedule device extension, and then another parent level, which would be the station which it came from. So using B format, then starting at that schedule, I could say parent.parent.name to return a string, which will be the name of the supervisor station. Then I could put maybe a pipe symbol, and we'll use another B format script here. In this case, again, we're starting from this global weekly here. And I'm going to just shift over to the property sheet real quick. I just want to look at it this way. It's a little easier to see probably. The schedule has a child property called ext, which is a Niagara schedule import extension. And that has a property called supervisor ID, which stores the slot path of that schedule, which is in the supervisor station. So I'm going to use a syntax here then, and just say ext to get the ext property, and then supervisor ID to get to the supervisor ID property under that schedule import extension. Now, that in itself should work for me just fine for the schedule imports here, but where this tag rule also applies to the schedules that are under the schedules folder here. And these don't have a schedule device extension under them, or schedule import extension rather. And so that would cause a failure of this B format syntax here being resolved, right? Which would be kind of ugly. So what I'm going to leverage here is the conditional switch syntax, a question mark, saying if that syntax fails to resolve, I want to use a lexicon call and go look up the Baja UI module and get the dialog.skip text or the text for the dialog.skip key out of the Baja UI lexicon. So this is just going to replace any kind of weird error with the word skip there in the tag value. So what I mean by that is if I look at my global weekly schedule here now and I look at the tags on it, we should see a schedule import tag here now, and the value is Vicom Pro Supervisor, right? Because it started at the schedule and it resolved that B format parent.parent.name, which came out to be Vicom Pro Supervisor. Then it put the hard-coded pipe symbol in there. and then it looked for the extension property and the supervisor ID property underneath that, and it stored the value, which happens to be the slot path to the schedule in the supervisor. If I look at the schedules under the home folder here at one of these, they will also have the same tag applied to them, because the tag rule applies to both of those. But you'll notice in this case it has the word skip there, indicating that this is not an imported schedule. Maybe it's a local schedule in the station, and you could use whatever substitution you wanted. I just used the dialog.skip key, but there's lots of other things that you can use as well. Right. Okay, so hopefully that makes sense. And then what we need to do is, at the supervisor end of things, we also want to modify the tag dictionary there to have the same information. So I've already done this part, but under the tag definitions, I added a schedule export and a schedule import tag under the tag definitions. And then taking a look at my tag rules, I have my weekly schedule tag here, which is looking for anything with the : schedule marker, and its name starts with global, right, which is going to find these global weekly, global Boolean, global numeric. It's going to find all those schedules. And we're already adding the weekly schedule tag to that, but we also want to add that smart B format tag to it here. And we'll call this sched export will be the tag ID for that one. Now, for this one, it's going to be a little bit different syntax, but really what I want to do is store the name of the station, and then also the slot path of the schedule itself, right? There's probably different ways that we could go about this. I could hard code it if I was trying to make this a little more flexible to be able to be moved somewhere. We can use component space, which will get the component space, and then root component, and then station name. So that syntax will resolve Vicom Pro Supervisor, and then I can put a pipe symbol and then %slot path, which will be the slot path of the schedule itself. So by doing that, then if I look at the tags on this global weekly schedule, then we'll see that there's this sched export tag, and it took that component space, root component station name, and it came up with Vicom Pro Supervisor, and then a pipe symbol, and then slot path of the schedule. So that's the same information that's stored in the sched import tag in the remote station. So I'll be able to compare those tag values and be able to line things up here in the station with the hierarchy. Right. Now, I've made modifications to the tags and tag rules in the J station and also in the supervisor station. So in this case, I need to go back to my system database service in the supervisor. And there's a couple things I need to do here. First of all, normally the local indexer is disabled. So I need to enable that local indexer. And that's going to index the things in the supervisor station itself. And it happens really fast typically. So it didn't really even see it change from an idle state, but it completed. So that mainly the thing I'm interested in is it's going to index the schedules in the supervisor station, like these global schedules here will get indexed into the system database. So my hierarchy can find those, and then we can map those down to the things in the remote J station. The other thing I need to do is probably trigger the global net indexer to run because I've made those changes in the remote station and I want to get the system database synchronized. Now, this will take a little bit longer because there's multiple stations. So I'll go ahead and pause the video and then we'll resume once the indexing completes. All right, so the indexing is completed there, and now we should be able to search for the things in the system database using the hierarchy in the supervisor. So this is my services under the supervisor, and I'm looking at the hierarchy service here. This is where I modified that schedule hierarchy. And I will add a new hierarchy to my supervisor. In this case, I'm going to go ahead and drag out a system DB hierarchy, and I'll call this exported schedules. And the main difference, again, between this hierarchy and this hierarchy in the palette is really just the scope. This one is already configured to use the system database as the scope where all the equal queries are resolved against. So the first thing I want to do is to search for these global schedules that are in the supervisor station. So to do that, I'll add a query level def here, and maybe just call this my schedules. And there's probably different things that we could look for, but in this case, we'll look for B:\weekly schedule, and we could also look for the schedule export value tag. So I can look for B:\weekly schedule and B:\sched export. So if I take a look at the hierarchy here, we'll see exported schedules, and I should see those schedules, those global Boolean, weekly, and numeric schedules that are in the supervisor station that are being exported potentially out to JSON stations. Now, probably would be a good idea here as well to then do a grouping based on the stations, so I can see what stations the schedules have been exported to. So I could use a group level def here, very similar to what I did in the other hierarchy example. And we can set this to n:\station, and that should give us again the grouping of the folders underneath each of the schedules. So if I look at my global weekly, with the group level def, if there's no children underneath, it won't show any of the groups. So we can set the include empty groups to true here on the hierarchy, and then refresh it and look at the hierarchy now. And when I expand that, it should show me folders for all the stations that it knows about under the system database under each schedule. All right. Now, we can also then add a query level def to search for the components in the system database that are the equipment that are controlled by those schedules. So we would go back to a query level def here, and I'll drop this onto the schedule or onto the hierarchy here and call this equipment. Now, again, there's no relations that go between the stations or anything, so I do need to have some idea of how I can compare the schedules that are exported in the supervisor and the schedules that are imported in the JSON station. So this is a prime example of where query context comes into play. On the initial query level def here, then I want to add a query context here, and I'll just call it sched export, and it'll be the B:\sched export tag is what I want to use as the tag value to store in that variable. And it's kind of hard to see in this field editor here, but you'll see it a little bit better here once I hit OK. So you can see I added a variable called sched export, and it's a string, and it's storing the value of the B:\schedule export tag in that query context. So then under my equipment query, very similar to what we've done before, I'll search for hsequip and n:\parent device relation that's inbound, and that's coming from a control point that has a B:\schedule ref relation that's inbound on it as well. And that schedule will have a B:\schedule import tag on it, and I want to check the value of that to make sure that it matches the schedule export variable that's stored in the query context. So that has the curly braces open and closing around the variable name that comes from the query context from this higher element in the hierarchy. I'll go ahead and refresh the hierarchy over here. And looking at my exported schedules and my global weekly has the Greenbrier station, and now it's showing the devices in the Greenbrier station, which are linked to the schedule import in the Greenbrier station, which is the imported schedule of this global weekly schedule from the supervisor. So I'm using those smart tags, the schedule export tag on the exported schedule and the schedule import tag on the imported schedule to help line things up using the query context here. So hope you found that interesting and understand how you can leverage that in your own applications, either with hierarchies in the local station or enterprise level hierarchies against the system database. Stay tuned for more Niagara Pro tip videos, and I'll be doing a third video in this series covering BACnet schedule exports, because it's a little bit different animal there with schedule exports instead of actual links then in that case. Have a wonderful day. Thank you for watching.